In this section of the MECH study group, we will be covering electrical. Approximately 20% of the questions asked on the MECH exam will be on the area of electrical, which means that about 20 of the 100 questions will be about switches and receptacles, light fixtures, ATS panels, emergency generators, electrical connectors, fuses and breakers, motors, wiring and conduit, control panels, and finally, battery backup systems. This is an important topic to focus on for the test, as it accounts for twice as many as most of the other areas, and combined with the general maintenance topic, the two account for nearly half of the questions on the test. We are going to be covering the following tasks that come directly out of the MECH test preparation manual. The candidate should know how to read electrical blueprints and electrical symbols, the function of a safety analyzer, understand Ohm's law and are able to use it in the field, the operation and diagnosis of single and three-phase motors, fluorescent lighting and ballast specifications, safety precautions and diagnostic methods, identify the load, common, and ground connections, motor starters and motor protectors, switches, relays, and various circuit types, including three-way, control, and others, the use and application of ammeter and multimeters, ground fault circuit interrupters, receptacles, and circuit breakers. The first area we will be covering is on how to read electrical blueprints and electrical symbols. On the first few pages of any electrical blueprints, there is a legend that consists of abbreviations, symbols, an index, a set of defining diagrams, multiple schedule types, and general notes. Every electrical blueprint set has single-line diagrams that give a detailed explanation of the main power sources. Along with the diagrams are panel schedules, home run schedules, lighting fixture schedules, the general symbols used, as well as general notes. The general notes are usually continued on every page of the blueprints. These items are essential in understanding what you are looking at and determining not only the location of a panel, circuit, fixture, or device, but the power source, voltage, service feeders, and circuits that are being utilized. One of the most important symbols anyone reading electrical blueprints should recognize and understand is the ground and grounding symbols shown in this slide. Some of the other basic symbols are contacts, circuit breakers, transformers, fuses, motors, batteries, outlets, switches, fixtures, and many more. More complex symbols include intricate detailed relays, automated transfer switches, and generators. The better you can understand each symbol, the more you will understand the hows and whys of each individual component of the power system, as well as how each system works together. Next, we will cover the function of a safety analyzer. A safety analyzer is used by healthcare professionals to perform electrical safety testing on medical equipment both in the field and in facilities. This multifaceted test instrument performs all primary safety tests, includes main voltage, protective earth resistance, insulation resistance, device current, earth, chassis, and patient leakages, as well as several additional leakage tests. Next, we will review Ohm's law and its uses in the field. There are three symbols involved in Ohm's law. V indicates the voltage drop of the resistor, measured in volts. I is the electrical current flowing through the resistor, measured in amperes. R is the resistance of the resistor, measured in ohms. This equation can be read as the electrical current flowing through the resistor is equal to the voltage drop of the resistor divided by the resistance of the resistor. For the next slide, you will need to note that V and E symbols are interchangeable, as indicated in the first bullet point. As long as you know two of the variables for the Ohm's law formula, you can figure out the third. The easiest way to find the variables is to use a meter, either a multimeter, ohmmeter, or a voltmeter. On the screen, you can see two ways that the equation can be rearranged, showing us that if we increase voltage, the current will increase. And if we increase resistance, current will reduce. In this section, we will review the operation and diagnosis of single and three-phase motors. Single-phase motors are a type of motor with low horsepower that typically operates on 120 or 240 volts of power. Three-phase motors are motors with a continuous series of 3 overlapping AC cycles offset by 120 degrees. For more information regarding definitions and the various types of motors, please visit the link shown on the screen. Each motor nameplate will clearly identify the manufacturer, motor type, output of the motor, often indicated in horsepower, amp and volt ratings, frequency indicated in hertz, number of phases, the rotations per minute, and oftentimes will have much more information specific to the motor. You will need to be intimately familiar with the differences of single-phase and three-phase motors and the applications each are used for. For more information regarding motors and their specific operation, please visit the link shown on the screen. Diagnosing electrical problems can be very involved, especially with today's complicated technologies. Anyone diagnosing motor problems should be familiar with electrical systems, lockout, tagout programs, the tools associated with diagnosing the issues, and should have received extensive electrical safety training. Being unknowledgeable in any of these areas may result in improper troubleshooting and ultimately lead to serious injury or death. Some basic tools that will be needed are a multimeter, MEGOHMMETER, or MEGR, wire cutters and strippers, and various sizes of screwdrivers. For additional information on basic diagnosis of electrical motors, please visit one of the website links indicated on the slide. Next, we will review fluorescent lighting and ballast specifications. Fluorescent lighting is a system of ballast and lamps that are typically used because of their efficiency and energy savings. Fluorescent lamps use electricity to excite mercury vapor inside the tubes, which in turn produce short-wave ultraviolet light that then causes the phosphor to fluoresce, which produces the visible light. Ballasts control the output of current to the individual lamps. Lamps come in various shapes and sizes with differing colors or hues. The two types of fluorescent lamps are CFLs, or compact fluorescent lamps, and tubes. Tubes use a T-number for the size in diameter and come in various lengths, typically 2, 4, or 6 feet. All fluorescents have a color rendering number designated with a K for Kelvin on the end, which determines the hues of the lamp. For additional information, please visit the link shown on the screen. An electrical ballast is a device intended to limit the amount of current in an electric circuit. A familiar and widely used example is the inductive ballast used in fluorescent lamps to limit the current through the tube, which would otherwise rise to destructive levels due to the tube's negative resistance characteristic. Next, we will review safety precautions and diagnostic methods. Diagnosing electrical systems and their associated problems can be extremely complicated and sometimes hazardous. Some of the basic electrical safety precautions you will always follow are: determine the qualified person, determine if working on energized or de-energized circuits, use proper meters, example of voltmeters, multimeters, and many others, verify circuiting and power source utilizing blueprints and other sources, follow appropriate procedures for de-energizing equipment, utilize proper lockout tagout procedures when necessary, use proper tools and PPE or personal protective equipment, seek additional assistance when necessary, and follow appropriate procedures for re-energizing equipment. This is not a comprehensive list, and anyone troubleshooting electrical systems should have the appropriate training to do so. For additional information regarding electrical safety precautions, please visit the links shown on the screen. Some basic diagnostic that you may use when troubleshooting electrical systems are to use electrical blueprints, manufacturer's wire diagrams, and single line diagrams, checking circuit controls, utilizing metering equipment described in upcoming slides, and checking or verifying the various components of the system. Next, we will review how to identify the load, common, and ground connections. Load is seen as the amount of electrical power required by the connected electrical equipment. The term load may also refer to the power consumed by a circuit. Facilities members should be careful with their use of the terms common and neutral because they can often be misrepresented by electricians. In Y, or a delta transformer, there are 4 wires, 3 hot wires and 1 middle wire called common wire or neutral wire, or sometimes it is grounded and called ground. When you connect between 2 hot wires, you get 220 volts. If you connect between the common and a hot wire, you get 110 volts. A ground is a conducting connection, whether intentional or accidental, between an electrical circuit or equipment and the earth or to some conducting body that serves in place of the earth. Next, we will review motor starters and motor protectors. A motor starter is an electrically operated switch that uses magnetic induction to provide the startup current for a motor. 4 common types are full voltage, in which the various types of full voltage starters include magnetic, reducing or reversing, and combination. This type of starter is typically used with circuit breakers. Reduced voltage is a reduced voltage starter is necessary for pumping motors to allow the motor to adjust to pressure before accelerating fully. Primary resistance starters are most often used with motors running conveyor belts carrying fragile items. Most commonly, Y delta starters are used by commercial industries for motors running appliances and lights. Motor protector is a term used to describe a bimetal thermal control used to protect an electric motor from overheating. 3 common types are power surge protection, which is the circuit breaker surge protector uses a disconnecting device or an emergency stop switch to bring the power surge to a halt. Thermal overload relays, which resistance temperature devices display the temperature of the motor and provide a warning when the motor appears to be overheating. Sensors, these allow preventive maintenance to be performed very quickly before the motor can malfunction and cause a loss of property and productivity or cause an injury. Next, we will review switches, relays, and various circuit types such as 3-way, control, and others. A switch is intended for use in general distribution and branch circuits. It is rated in amperes and is capable of interrupting its rated voltage. A 3-way switch is an electric switch that has 3 terminals, used to control a circuit from 2 different directions or locations. A relay is an electromechanical device operated by a small amount of electricity to control a larger amount of electricity. Relays are used for both control and safety. A closed circuit has a complete path for current to flow. An open circuit has an incomplete path or broken path so that current cannot flow. A short circuit is a low resistance path, usually caused unintentionally, that bypasses part of a circuit. A series circuit is a circuit in which all parts are connected end to end to provide a single path for current. A parallel circuit is a circuit in which the elements, branches, or components are connected between 2 points, with one of the 2 ends of each component connected to each point. Next, we will review the use and application of an amp and multimeter. An ammeter is an instrument used to measure the electric current in a circuit. It only has the ability to measure amperes. Instructions include: gain access to the power wire that is feeding current to the electrical device. Generally, this will be in the circuit breaker panel or the device's electrical wire makeup box. Next, turn the meter on. If a digital type ammeter, and set the range of the meter in the area of the identification tag that is on the device. In other words, if the device is supposed to draw 10 amperes of current during normal operation, you will want to set the meter in that range of reading the current draw. Most meters may have multiple range settings for the ammeter. Next, open the clamp by depressing the thumb trigger on the side of the ammeter. This will open the jaws of the handheld meter. Place the jaws around the wire and close the clamp. The clamp must be fully closed, properly seated, in order to receive an accurate reading from the power conducting wire. Allow a few seconds for the meter to register the amperage reading on the display. Test the other wires that are feeding the device if there are multiple feed wires, such as a 220 volt AC 2-wire or a 3-phase 3-wire power circuit. All of the power wires, if multiple feeds are used, should be close in the amperage reading to each other. Next, remove the clamp on meter from the circuit when finished and shut the meter off so as not to wear down the battery. Some meters may have an automatic shutoff to conserve battery power. A warning for clamp type ammeters is that only AC circuits can be tested with this type of meter. Multimeter, also known as a multi-tester or a VOM, volt-ohm meter, is an electronic measuring instrument that combines several measurement functions in one unit. It has the ability to measure voltage, current, and resistance. Instructions include: first, turn on the multimeter and connect the probes if necessary. The negative probe is black and the positive will be red. For some applications, this is important, while for others, it does not matter. Use the probes to measure resistance by placing one on each side of the component to be measured. For this function, the probes are interchangeable. The item being repaired should be turned off and the multimeter set to resistance, which may be symbolized by a horseshoe-shaped icon. Note the numbers on the display. This is the resistance measured in ohms. Some multimeters have the ability to check for continuity or unbroken connections in wiring. This is checked in the same way as resistance, except the meter is set to continuity, symbolized by a series of diminishing curved lines. Continuity is indicated with a tone. Measuring voltage requires the electricity to be on in the device being measured. To measure DC voltage, set the multimeter to VDC. Touch the negative black probe to ground and positive red probe to the point in the circuit where DC voltage is to be checked. The voltage reading in volts will register on the display with a negative symbol indicating voltage toward ground. A positive symbol may or may not be displayed to indicate voltage moving away from the ground. To measure AC voltage, set the multimeter to VAC. The reading will also be in volts, although there is no direction to AC voltage. Checking diodes is accomplished by setting the multimeter to diode check, which may be symbolized with an arrow against a vertical line. Turn the device off and measure the diode by placing the negative probe on the cathode of the diode, frequently indicated by a stripe around the end of the diode, and the positive probe on the anode, unmarked side. Most multimeters will first make a tone, like when indicating continuity, and then display the voltage drop across the diode. This varies with the diode type, but it is typically between 0.5 and 0.75 voltages. Reading capacitance on meters equipped with this option requires removing the capacitor from the circuit unless the meter measures in circuit capacitance. This is almost always a feature only found in meters designed for this purpose. After removing the capacitor, set the meter to capacitance, which is often symbolized by a curved line and a vertical line. Some capacitors have a positive and negative side, others do not. If there is a negative side, it will be indicated by a stripe or even negative symbols. And the negative probe should be placed on that lead, positive on the other. If a negative side is not indicated, then probe orientation will not matter. Capacitance measurement will take several seconds to register and will display in farads. Turn the meter off when not in use and store the probes so they will not be damaged. MEGOHMMETER is a special type of ohm meter used to measure the electrical resistance of insulators. Instructions include: Remove all power from the wires or circuit to be tested. There can be absolutely no voltage connected to the circuit when these high voltage tests are being conducted. Uninstall all wires that are to be tested. This means that any wire that is to have the insulation value checked must be completely disconnected on both ends of the circuit. The bare copper ends are sometimes covered by a wire nut or a piece of tape. This protects equipment or someone from being shocked. In the case of testing motors, all wires feeding the motor must also be completely disconnected. Next, connect one of the Megger's leads to the electrical frame or earth ground of the electrical system. In testing motor windings, this lead will be connected to the actual metal frame of the motor. Next, attach the other lead from the meter to the bare copper end of the wire, or one of the motor terminals. Check to be sure the other end of the wire being tested is in free air or covered by an insulator such as a piece of tape or wire nut. Turn the meter on or begin to crank the generator handle. It may take 2 to 5 seconds for the high voltage to build inside the wire or motor windings. Next, read the meter. A reading of greater than 999 megohms is a near perfect resistance reading for a wire or a new motor. Resistance readings less than 1.5 megohms may present problems in old wires or used motors. In most cases, any reading in between these values may be fine, unless trouble has been experienced in these circuits. Next, continue to test other wires or the remaining motor terminals. Once the meter's high voltage source has ceased, the wires or motor leads are safe to handle. A tip: caution must be exercised when using a megohm meter, as serious damage and injury to parts and personnel can occur from improper use. Next, we will review ground fault circuit interrupters, also known as G.F.C.Is, receptacles, and circuit breakers. G.F.C.I protection may be installed at different locations within a circuit. G.F.C.I receptacles may also be connected to provide G.F.C.I protection at all other receptacles installed downstream on the same circuit. G.F.C.I circuit breakers, when installed in a load center or panel board, provide G.F.C.I protection and conventional circuit overcurrent protection for all branch circuit components connected to the CB. Receptacles come in various sizes, configurations, and amperes, specifications depending on the usage or equipment needs. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by overload or short circuit. Its basic function is to detect a fault condition and, by interrupting continuity, to immediately discontinue electrical flow. We will now go over the test questions covered in the MECH test preparation manual. You can follow along in the booklet, as there are some complicated diagrams in the manual that are referenced in this review. CAT test question 1. Electrical switches and receptacles are replaced with A, the white wire connected to the silver terminal, B, the black wire connected to the brass terminal, C, the green wire attached to the green terminal, or D, all of the above. Answer D is the best answer here, because answers A, B, and C are all correct. As you can see in the pictures, the power source or power in starts at the switch box. Circuit electrical wiring enters the switch box, and then the power in source attaches to one of the brass switch screw terminals. Fixture wiring exits the switch box. The black wire or the power out wiring attaches to the other switch screw terminal. The white neutral wires splice together, and the white ground wires splice together and bond to the switch and the box. CAT test question 2. Electrical connections are checked for A, loose screws and black smudge marks, B, hot terminals where wires connect, C, both A and B, or D, neither A or B. Answer C is the best answer here because both answers A and B are correct, as indicated by the photos on the screen. CAT test question 3. Lockout-tagout is A, tool used to check the system for power, B, procedure sometimes followed by the supervisor, C, safety procedure to prevent electrocution, D, safety procedure for electrical equipment. Answer C is the best answer here. Answer A is not correct because lockout-tagout is a procedure that sometimes utilizes tools. Answer B is not the best answer because the procedures are used by frontline staff, contractors, supervisors, and management, and when in effect, should always be adhered to. Answer D is not the best answer because though lockout-tagout is a safety procedure, answer is too specific in its use of the term electrical equipment. Answer C is the best answer because lockout-tagout is a safety procedure to prevent electrocution. CAT test question 4. Battery levels need to be checked for A, oil level, B, water level, C, acid level, D, voltage. Answer C is the best answer here. The lead-acid battery is made up of plates, lead, and lead oxide with a 35% sulfuric acid and 65% water solution. This solution is called electrolyte, which causes a chemical reaction that produces electrons. When you test a battery with a hydrometer, you are measuring the amount of sulfuric acid in the electrolyte. If your reading is low, that means that the chemistry that makes electrons is lacking. Hydrometers are used to A, determine the battery charge, B, determine the acid content, C, both A and B, and D, neither A or B. Answer C is correct here. Similar to the previous question, when you test a battery with a hydrometer, you are measuring the amount of sulfuric acid in the electrolyte and therefore determining the battery charge. If your reading is low, that means the chemistry that makes electrons is lacking and the battery charge is low. CAT test question 6. Electrical cords that cross a walkway should be placed in A, cord protector, B, conduit, C, plastic pipe, D, floor trench. Answer A is the best answer here, as shown in the photo on the screen. Answer B and C are not correct because they could be a source of trips and falls. Answer D is not the best answer because a floor trench may not be available in all applications, and electrical cords should be used only on a temporary basis. CAT test question 7. When replacing a fuse, the fuse should be A, a glass fuse, B, a bar fuse, C, the one recommended by a manufacturer, or D, the same type and amperage rating. Answer D is the best answer here. Answer A and B would not be correct because you would not want to change the type of fuse if that was not the original, i.e. switching from a thermal or resettable fuse type. Answer C is not correct because though the manufacturer may make a recommendation or range for the equipment, numerous other factors could come into play, such as equipment downstream or variations in voltage. CAT test question 8. Breakers are reset only A, if there is nothing plugged in, B, when all appliances are off, C, after the circuit has been checked for shorts, or D, when there are no frayed cords. Answer C is the best answer here. Answer A and B are not necessary in every situation and therefore are not the best choices. Answer D is surely desirable, but may not be the reason for the breaker tripping and is therefore not pertinent to the question and not the best answer. CAT test question 9. Motors that smell burned or that have gotten hot should be checked for A, locked rotors, B, shorts and open circuits, C, faulty start switches, or D, bad capacitors. Answer B is the best answer here. Though answer A, a locked rotor, could cause the motor to heat up, The cause could also be from the motor bearings, and therefore not the motor. Answers C and D are not the best answers because faulty switches and bad capacitors will likely not make the motor hot. The most likely cause is shorts and open circuits, so the best answer here is answer B. CAT test question 10. A 2 ohm resistance across a set of contacts indicate that the A, motor will not start, B, start capacitor may not function, C, contacts may need to be replaced, D, motor should be removed from service. Answer C is the best answer here. A 2 ohm resistance is indicative that the contacts have wear and may need to be replaced. Answer A and B are not the best answers because the motor and start capacitor may still function normally. Answer D is not the best answer because without some other indication of failure or improper operation, the motor can likely still be used until the contacts can be replaced. Comp Test 5, question number 3. The purpose of grounding electrical circuits is to A, protect equipment from damage, B, protect the building from lightning, C, assure personal safety, or D, lower circuit resistance. C is the best answer here. Grounding is the connecting of electrical equipment and wiring systems to the earth by a wire or other conductor. The primary purpose of grounding is to reduce the risk of serious electric shock from current leaking into uninsulated metal parts of an appliance, power tool, or other electrical devices. In a properly grounded system, such leaking current, called fault current, is carried away harmlessly. Grounding is also used in manufacturing industries to prevent accumulation of hazardous static electrical charges. Answer A and B are not the best answer because other electrical systems have fuses or circuit breakers for protection to protect against a major fault current or short circuit, and the building has a standalone grounding system to protect from lightning. The human body may be fatally shocked by a current of less than 1 ampere, well below the point at which a fuse or breaker will operate. Grounding helps prevent such a hazard from occurring. Answer D is not the best answer because grounding of electrical circuits has no impact on lowering circuit resistance. Comp Test 5, question number 4. Soot streaks on an electrical outlet indicates that A, the outlet could have an internal short, B, plastic insulation material may have broken on the inside, C, a device that was plugged in became defective, or D, it's possible that one or more of the above could have caused the soot. Answer D is the best answer here because answers A, B, and C are all potential causes of the soot streaks on an electrical outlet. Comp Test 7, question number 3. For this, please refer to the MECH test preparation manual for the associated figure. In the figure, the symbol C4 means A, the number of circuits between light fixtures, B, the circuit breaker number in panel C, C, there are 4 wires in the circuit, or D, has no significant meaning. Answer C is the best choice here because there are 4 wires in the circuit. Answers A, B, and D are all incorrect. Note that facility staff members should always refer to the legend on the electrical prints, as designers may use different methods for indicating the number of wires in a circuit. An example is that hash marks are often used to indicate a circuit, and that is one method that may be used. Comp Test 7, question number 4. The switching in an electrical circuit should always occur in the A, ungrounded conductor, B, main panel, C, ground, or D, grounded conductor. Answer A is the best answer because the ungrounded conductor is the hot line as shown in the photo on the screen. The black line is the hot line, which is being controlled by the switch. Comp Test 8, question number 3. When a circuit breaker trips, which one of the following conditions has occurred? A, large circuit voltage. B, amperage decreases. C, loss of power. Or D, overloaded circuit. Answer D is the best answer here because circuit breakers are an automatically operated electrical switch designed to protect an electrical circuit from damage caused by overload or short circuit. Answers A, B, and C are not correct because circuit breakers do not protect against large circuit voltages, amperage decreases, or losses of power. Comp Test 8, question number 4. The possibility of an electric shock increases when you touch A, high temperature surfaces, B, masonry surfaces, C, minerals and salts, or D, metal pipes and tanks. Answer D is the best answer here. Answer A is not the best answer because temperatures generally do not affect the conductivity of a surface. Answer B and C are not the best choice because many masonry surfaces, minerals, and salt are not conductive and therefore do not increase the possibility of electrical shock. Comp Test 9, question number 3. The purpose of the ballast in a fluorescent light is to A, limit the current flow through the tubes. B, increase the input voltage. C, provide a greater inductance effect. D, keep the temperature in the fixture constant. Answer A is the best answer here. An electrical ballast is a device intended to limit the amount of current in an electric circuit. A familiar and widely used example is the inductive ballast used in fluorescent lamps to limit the current through the tube, which would otherwise rise to destructive levels due to the tube's negative resistance characteristic. Answer B, C, and D are not the primary purpose of a ballast and are therefore not the best answer to the question. Comp Test 9, question number 4. If the light within the fixture is flickering, the possible causes might be A, voltage drop in spikes, B, bad bulb or ballast, C, faulty wiring, D, all of the above. Answer D is the best answer here because answer A, B, and C are all correct answers. Comp Test 10, question number 3. A piece of equipment operated by a magnetic starter, A, will run hot and continuously regardless of power failure. B, will restart unexpectedly after a power failure. C, will not restart unexpectedly after a power failure. D, none of the above. Answer C is the best answer here. As the circuit fails in the open de-energized position, and must be operated manually to turn back on. Answers A, B, and D are all incorrect. Comp Test 10, question number 4. A 2-pole single-phase motor will run at A, 1,140 RPM, B, 1,725 RPM, C, 3,450 RPM, D, 4,025 RPM. Answer C is the best answer here, and it is calculated using the formula now shown on the screen. We know that the voltage is 120 volts, the frequency is 60 hertz, and the number of motor winding poles is 2, giving us answer C as the best choice. Comp Test 11, question number 3. The armature is a rotating component in A, split-phase motor, B, shaded pole motor, C, repulsion induction motor, or D, 3-phase motor. As shown on the screen, answer C is the best answer here, as an armature is a rotating component in a repulsion induction motor. Answers A, B, and D are all incorrect because they do not have rotating armatures. Comp Test 11, question number 4. In a split-phase capacitor start motor, the start windings are A, larger gauge than the main windings, B, the same gauge as the main windings, C, smaller gauge than the main windings, D, different gauges dependent on motor size. Answer C is the best answer here. The windings are unlike and thereby split the single phase of the power supply by causing a phase displacement between the currents of the two windings, thus producing a rotating field. After the motor has attained approximately 75% of rated speed, the starting winding is automatically disconnected by means of a centrifugal switch or by a relay. The motor then continues to run on a single oscillating field, which in conjunction with the rotation of the rotor results in a rotating field effect. Since there is no rotating field, after the starting winding is de-energized, the rotation cannot be changed until the motor has come to rest, or at least slowed down to the speed at which the automatic switch closes. Comp Test 12, question number 3. A MEGOHMMETER or a MEGR is used to determine A, if a motor winding is grounded, B, the number of copper meg bars on a three-phase rotor, C, the ambient temperature of a motor control, D, ampere rating of the locked rotor rating, Answer A is the best answer here. MEGOHMMETERs or MEGRs are a special type of ohm meter used to measure the electrical resistance of insulators. As insulators break down, the potential for motor windings to ground increase. MEGRs do not determine the number of copper meg bars, the ambient temperature of a motor control, or the ampere rating, and thus answers B, C, and D are all incorrect. Answer A is the best answer here. Comp Test 12, question number 4. To change the direction of a split-phase motor, it is necessary to A, switch the connection of the start winding leads, B, change the number of stator poles, C, change the size of the capacitor, D, switch the start and main winding leads. Answer A is the best answer here. As seen in the photo on the left, no matter which two starting winding leads are swapped, it ultimately reverses the phase rotation and changes the direction of the split-phase motor. Comp Test 13, question number 3. Heater on the magnetic starter are the A, motor pre-start warming circuit, B, oil reservoir heaters, or C, overload protection system, or D, heat dissipation system employed in the motor design. Answer C is the best answer here. Heaters on a magnetic starter provide overload protection. Heaters on a magnetic starter do not provide a motor pre-start warming circuit, do not function as oil reservoir heaters, and do not provide heat dissipation employed in the motor design, and therefore answers A, B, and D are all incorrect. Comp Test 13, question number 4. A motor control alternator is used to alternate the A, current to a motor, B, sequential operation of two motors, C, starting circuit, D, capacitors. Answer B is the best answer here. Answer A is not correct because current to a motor is not used to alternate current to a motor. Answer C and D is not the best answer because starting circuits and capacitors will each have their own internal to the motors. Comp Test 14, question number 3. If you had power at L1 and L2 of a magnetic starter, but the relay will not pull in to operate the equipment. You would check the A, reset switch, B, heaters, C, relay coil, or D, power supply. Answer A is the best answer here. All of the answers for choices B, C, and D could de-energize the circuit. However, the reset switch is the easiest and only one that will maintain power at L1 and L2, but not allow the relay to pull in to operate the equipment. Comp Test 14, question number 4. A change in the speed of an electric motor can be done using A, a brake, B, the next size belt for a given pulley, C, a higher voltage, D, a variable frequency drive. Answer D is the best answer here because a variable frequency drive is a type of adjustable speed drive used in electromechanical drive systems to control AC motor speed and torque by varying motor input frequency and voltage. Answer A is not the best answer because a brake will not provide the control needed to maintain speeds at a desired level. Answer B is not the best answer because a different size belt will only alter the driven equipment speed but will not alter motor speed. Answer C is not the best answer because increasing the voltage to an AC motor will increase its torque, the force it can turn when attached to a load, but not its speed. Comp Test 15, question number 3. Refer to the wiring diagram in the MECH test preparation manual for this question. This is a wiring diagram for A, start winding circuit for a 3-phase motor, B, 3-phase magnetic starter, C, potential magnetic 3-phase starter, D, current magnetic 3-phase starter. Answer B is the best answer here because the wiring diagram shown is for a 3-phase magnetic starter. For additional information on this topic, please visit the website shown on the screen. Comp Test 15, question number 4. A light switch switches on and off the A, neutral wire to the light, B, the hot wire to the light, C, the ground wire to the light, D, the neutral wire to the switch. Answer B is the best answer here because a light switch switches on and off the hot wire to the light. This is shown on the screen as a simplified diagram of a light switch and a light. Comp Test 16, question number 3. Refer to the wiring diagram in the MECH test preparation manual. This is a wiring diagram of A, current magnetic starter, B, across the line starter, C, stop-start switch, D, potential magnetic starter. Answer C is the best answer here because a stop-start switch is the wiring diagram shown. For additional information regarding simple stop-start switches, please visit the link shown on the screen. Comp Test 16, question number 4. Voltage is described as A, the opposition to the flow of electrons in a wire, B, the cross-sectional area of a conductor, C, the electrical force where 1 volt causes an electron flow of 1 ampere through a resistance of 1 ohm, C, the dynamic flow of electrons. Answer C is the best answer here, as it fulfills the definition of voltage. Answer A is not the best answer because it is describing resistance. Answer B is not the best answer because it is describing AWG, or American Wire Gauge. Answer D is not correct because it is describing the electricity in general. Comp Test 17, question number 3. Refer to the MECH test preparation manual for this question. The total assembly of components in these pictures depicts A. Heaters, B. Thermal relays, C. Reset switches, D. Heat sensors. Answer B is the best answer here. A thermal relay is a type of overload relay that connects a heater with a motor. A thermal relay protects a motor by shutting it down if the relay detects excessive heat. Comp Test 17, question number 4. Current in a wire is measured by A. Volts, B. Amps, C. Ohms, D. Watts. Answer B is the best answer here. The unit for measuring an electric current is the ampere, which is the flow of electric charges through a surface at the rate of 1 coulomb per second. Electric current can be measured using an ammeter. For additional information about using an ammeter, refer to the previous slides of the presentation. Comp Test 18, question number 3. Continuity of a wire can be checked with A. Megger, B. Voltmeter, C. Proximity checker, and D. Test light. Answer D is the best answer here. Answer A is not correct because a Megger measures the electrical resistance of insulators. Answer B is not correct because a voltmeter measures electrical potential difference between 2 points in an electric circuit. Answer C is not correct because a proximimeter checker indicates whether a wire is hot. A side note is that many multimeters these days have continuity checking capabilities, and test lights are built in as a feature. Comp Test 18, question number 4. The type of ladder that should not be used for electrical work is A. Step ladder, B. Extension ladder, C. Wooden ladder, or D. Aluminum ladder. The best answer here is D. Aluminum ladders have a potential for conducting electricity and are therefore the poorest of choices available. This completes the electrical portion of the COMPETENCIES study group for MECH exam.